Welcome, welcome. I hope you've all had a lovely Monday. So for today's session, we're going to be continuing with what we covered in last week's session. So we started to build out this little typing game. If you missed the previous session, you can get all of the code at this URL that you can see up here. I've pasted it into the chat already. I'll paste it in again. And what you're going to do is, if you go to that URL and then you click on this remix button, you can see here, then you will get a copy of this code yourself. If you're coding along on a later video, I will share. In fact, you can get the starter code from last week's video, so that's probably the best way to go. So we're going to continue on, and then what we're going to do is we'll go over some of the techniques that we've used while building this game and actually take a deeper dive into them now that we've seen what they look like. So last week we got to the point where we have created this, let's call it a game in inverted commas. So we can click on Start Game. It's saying type me, so we're going to type. If we make a mistake, we get some sort of error indication. If we get it right, we get our congratulations. So this is where we got up to last time. We have a game, we can type in a box, it can tell whether we've typed it correctly or incorrectly, and it can tell when we've finished the game. But at the moment, it's not a particularly exciting game, and it isn't really, it isn't a game. We don't have any kind of scoring system. We don't have any way to know like how quickly you typed. So we are going to put in a timer, which is going to tell us how long it took for us to type the sentence. And JavaScript has a date object built into it that is going to help us keep track of how long it takes to type all the words. So we're going to introduce a new variable, which we're going to call start time. And what we're going to do is that is going to get the time that it is at the point where you start typing. Then we're going to time how long it takes for you to finish typing and get that time -1 from the other, and we will find out how long it took for you to finish. So let's put in that new variable. So we've got our let here with our word queue and our quote text and our highlight position. So we're going to add in a new variable in here, which we're going to call start time. And then we're going to set that start time at the point at which we start the game. So we've got our start game function here. Can you all see that text, by the way? Is that big enough, or do you want me to zoom in? It's all right, okay. So we got this start game function here, and at the end of our start game function, we are going to get that start time. So we're going to say start time is new date of get time. And what that is doing is it's going to create a new date. And date is an object, and we've had a look at JavaScript objects. And on that object is a method called getTime, which is going to return a number. And the number that it returns is the number of milliseconds since January the 1st, 1970, which seems a bit weird because computers are weird. And you will see this number everywhere. It's called the Unix epoch. And so January the 1st, 1970 is when JavaScript considers time to have started. And what it's going to do is give you the number of seconds since January the 1st, 1970. And then we're going to convert that into a time that actually means something to us. So then what we want to do is we want to find out what time it is when you finish the game. And we can do that in our game over function. So if we scroll, let's scroll and find our game over function. Here it is. So in our game over function, we're going to create a const, which is going to be called elapsed time. So let's put that right at the top. So we want to get the time as soon as the game finishes. So we're going to put in const elapsed time. And the elapsed time is going to equal the time at the moment minus the start time. So we're going to do the exact same thing. We're going to create a new date object. We're going to call get time on that. And then we're just going to minus start. And then what we want is we want to know the number of seconds that was. And our epoch is given to us in milliseconds, I believe. Yes, milliseconds. So it's milliseconds since the epoch. So what we want is to, what have I forgotten that? Oh, an equal sign. There we go. What we want to do is divide that number by 1,000 in order to get seconds. So it's giving us the time in milliseconds. We want to get the time in seconds. So after our, we've got this message which is saying, congratulations, like you finished. We're going to put in now a BR. And after the BR, we're going to say, let's drop this onto a new line so we can actually read it. And this is the nice thing about using our backticks. We can actually put new lines in it. So we've got a BR, and then we're going to put in new finish in. I'm going to use our curly bracket and $sign selector. Elapsed time over 1,000 seconds. So what we're doing here is getting this elapsed time here, dividing it by 1,000 to get it in milliseconds, and then outputting it into this string of text here. So now when we finish, we should get a time. Hello, welcome people who joined. If you scroll back into the chat, you can find the link to get the code, which is where we are up to right now. So now, if I click on start game, congratulations, you finished in 4.094 seconds. So that's cool. This is feeling a little bit more like a game now, and we get to see the total time taken. So now what we want to do, so I set you all some homework last week, and if you're new here, don't worry about it too much. But the homework was to pick a few fun quotes so that we can actually give them something more exciting to type than just the words type me. So that's not very exciting. So we are going to put our quotes in into here. In fact, we're going to make a new variable where we're going to put our quotes in, and then we'll insert those into here. So let's make a new variable. In fact, let's put it right at the top. Okay, so const quotes equals, and it's going to be an array of quotes. If start time is created in function start game, how is it seen in another function? Asks somebody. So it isn't created in start game. Start time is actually global. We've created it outside of the start game, but then we've set it. into the start game. So it gets a value at this point. That's cool. No need to ask. Bedros, I'm not even going to go into that in a beginner's lesson, sorry. Wait, what does it do? I'm so confused. Leah, this is a game that we are building that is a little typing game where we are creating a game where we start typing. It gives us a quote, we type out the quote, it tells us how long it took us to play that game. We started building it last session. If you want to join in this session, you can go to this URL here and get the code. And if you click on the remix button, you can get a version of it yourself and you can type along with me. And then what we're going to do is we're going to talk through some of the things that we used. Cool. Okay, so let's write some quotes in here. So if you collected quotes from your favorite movie or your favorite book or your favorite philosopher or whatever you would like to do, you can absolutely use them here. And the way we're going to do it, we're going to make an array of strings, and each quote is going to be a string, which is just a load of text. I'm going to quickly type mine out. Mine are a bunch of Star Trek quotes because I'm a nerd. You can Google and find your own quotes. You can theme this game however you would like to. You would think that I might have collected these somewhere where I could copy and paste them, but I have not. String then is going to be followed by a comma. While I'm typing this, it gives you all a chance to catch up. So I'm just going to keep doing this. We love these Star Trek inspirational quotes. Okay. That's enough quotes for now. Not sure what question you're asking there. So that is our collection of quotes. What if I put some comma? Oh, I see why. This quote set is what I want. Yep, so what we've done now is we've created an array of quotes. Now what we want to do is pick a quote that is going to be played by the game. One of my quotes has an apostrophe. If your quote has an apostrophe, you can use double quotes instead to surround your string, and your apostrophe will be legitimate. It'll be contained as part of the string. Or you can escape it, or you can like use is not instead of like isn't. It's up to you. Or backtick is Petros. Right, you mentioned. Cool. Yes. So what we're going to do next is we need to pick a random quote from our set of quotes, which is the one that's going to be played. Randomness in JavaScript is kind of weird, but we're going to do. Let's make a new. Let's put it in our start game right at the top. So after we have said game started, we're going to, so each of our quotes in an array has an index. So we looked at this very briefly last week, and we said we're going to start 0, 1, 2, 3, 4, 5. So I've got 6 quotes in there counting from 0. So what we want to do is pick a random number between 0 and the number of quotes in your list. So for me, it's between 0 and 6. 0 and 5. For you, it's however many quotes that you have. So we're going to create a new variable, which is going to be that random number. So we're going to say const quote index. Math floor math.random multiplied by quotes.length. So what is happening is math.random is giving us a random number. Math.floor is rounding that to the nearest whole number. And then we're multiplying that by quotes.length. So this is going to give us an index between 0 and the number of things that we have in the array. This is horrible. I don't expect you to remember this. Every time I have to use it, I have to Google it. Don't worry too much about it. This is how you get random numbers between 2 numbers in JavaScript. And then we want to actually select the quote that is at that index. And the way that we're going to do that is by saying const quote text equals quotes. So our quotes array, and then the item that is at that index that we just made, quote index. Now we can get rid of our quote text equals type name because we have now set up quote text. So that's cool. You might have punctuation in your quotes. I have some punctuation in mine, like there's a semicolon here, you've got a couple of commas, there's a full stop. And it's kind of up to you whether you want your players to have to type that. I think it kind of ruins the flow of the game. So to make it a tiny bit easier for our players, and maybe to make 2 quote text variables. Yes, we can get rid of quote text from here now. Thank you for noticing. Yeah, to get rid of the commas, the full stops, the any other punctuation that you might have in your quotes. What we're going to do is we're going to do a replace all on the current word. So when we say current word equals word Q0, we're going to do And this is going to feel a bit long-winded and a bit horrible, but we're going to replace all. We're going to replace our full stop with nothing. And we're going to replace all comma with nothing and replace all. For me, I've got a semicolon in there, so I'm going to get rid of that as well. It's nothing, and that should just sort of patch those bits of punctuation so that the player doesn't have to type them. It just means the players won't trip up when they're working on typing as fast as they possibly can. You don't need to do this, but when I was testing out the game, it sort of wasn't fun with the punctuation in there. So I think it makes the game more fun not having to type the punctuation. So let's have a go at actually playing our game now. So if we start game, it would have chosen the longest quote, wouldn't it? Woohoo! So I finished in 20.758 seconds. So that's our game. You've built your first JavaScript game, I hope. I'm gonna just give everybody the opportunity to catch up, to ask any questions. Thank you, Bedros. That's a great explanation about what is happening with our random numbers. Once you are happy with what you have got, we are going to put some styles in, because at the moment it looks kind of boring. So do ask any questions. If you're still collecting your quotes, have a go at typing those. I would really love to see the games that you're building, so please do share the URLs. But let me get you some CSS that we can all type in, and yeah, then because we've already covered CSS in the previous lesson, I'm not going to go over styling each individual element in this thing. I'm just going to give you some CSS that will style it for you. So let me just find that right now. Can you explain string 20? Do you mean line 20? You mean line 20, then Bedros's explanation that he's literally just typed one above is actually a really great explanation of what is happening there. Okay, CSS coming. Sorry, I'm just waiting for the glitch to load. Okay, CSS. Oh, hold on just a second here. So if you jump into my glitch, you should be able to copy and paste this whole thing to get some starter CSS. Different class names, which is maybe broken or something. That isn't looking as pretty as I would like it to. To this, let me see if I can get a direct URL to the CSS. If you want to copy and paste the CSS into your CSS, that's the URL that you want. Let's see. Great. Okay. So we've got some styles, but some styles are not working. I'm not sure why that isn't centered. So let's have a look at what's happening there. So we've got our input, which has an ID of typed value. Selected for typed value in here. No, it's just not put in the middle. So why don't we put it in the middle? Margin, no, auto. Sit in the middle. There we go. Okay, that's a bit better. And at the moment, the game end is a little bit kind of a little bit boring. If we click on start, oh, giving me the long quotes again. If I can make a short one. Yeah, I mean, like, okay, so we've got a big old congratulations on there, but I think we can do a bit better than that. So we're going to make the game over screen a little bit more exciting. And the way that we're going to do that is we're going to add a class to the body, which is going to make it possible for us to restyle the whole page when the game is finished. So in our start game, we jump back into our JavaScript. In our start game, we are going to put a class on the body of started. So why don't we do that right at the bottom? We're going to say start.class name. Ah, I see. This is putting a style on the button, isn't it? We're going to get rid of the button so that we can't start the game twice. And we are going to put a class on the body in the game over. So at the bottom of our game over, we will say dot body dot class name. Winner. So we're putting a class of winner on the body there. And then what we want to do is remove the class of winner when the game starts. So we're also going to say document dot body dot class name is empty. So we're just going to set it to an empty string there. So we're removing that winner class. And then we will add a style into our CSS so we can style up the winner. And we're going to add a transparent background image of some confetti to our game. So a load of confetti will pour down the screen when you finish the game. So if we jump into our CSS, we can write at the bottom, make a new selector for our winner. A background image. with a URL, and we need to actually get that confetti animation. So let me just try and find where I put that. Go. The URL for the confetti animation here. So what you want to do is you want to go to that URL, right click and save it onto your computer and save it as like confetti.gif or something. Then what you can do is you can upload it to Glitch, upload that confetti. Got a nice little confetti GIF. I also made you a little rocket asset, which you can add into the start button. So if you want to add in, if your game is also space themed, you can. The link isn't working. I wonder. I wonder if that's because I'm logged in. Let's see if now that I've uploaded it here, I'm able to access this. Or if you go to my Glitch and remix it now, you might be able to get the asset as well. Joy with that second link. You got it. Okay, cool. Yep, so if you've also done a space themed game, I made a little rocket button for you, in a rocket image. If you don't have a space game, you can also put your own icon in the button. So yeah, so the rocket, let me get you the URL for that. So you're going to do the same thing, save the image. So, the asset. Rocket. So now if I refresh, maybe that rocket would show up. That worked. We might need to update the CSS. But what I'm going to do is open up my confetti, then copy this URL here, copy URL, and then back into our CSS. That winner is going to the URL straight into there. I don't know what illustration.svg is. That's just something that Glitch has provided, so you can completely ignore that. Don't worry about it. I think that was something that Glitch provided as part of the default. Remember when we created the project, it gave us like a default page with some styles on it and we deleted it all. I think that's just left over from that. So if you've got the default, the illustration.svg, you can just delete it. Don't worry about it. Yep. So we've got our winner now. First used at line 105. Have I already? Oh, sorry. Glitch is really great, actually. It didn't used to do any of these suggestions for you. This is nice. Okay, and what's it complaining about here? That this should be below select icon. Right, but our button is still not getting that. That's because we changed the name of it to start, didn't we? So if you change that to the start, we might get a little. Back into our HTML. What do we call our button? Button type. Oh no, it is a class of button. Ignore me. So that was the selector button. That should just be button. Oh, I know what the problem is. We haven't updated the URL. So we need to go back into our assets, get that little rocket or whatever icon it is that you decide to use in your button. Jump into your CSS. Update that URL that is on the rocket. Maybe my rocket is going to show up. And then happening here? Why is our button? Massive button. Why are you not getting the rocket style? It's just not trying look at all, isn't it? Still not there. Mistake in my JavaScript. Start dot class name equals started. Where have I put that class of rocket? I don't think we have that anywhere at the moment, do we? Oh, I see. We're putting an icon in the page. It's not a pseudo class. So what is happening here when we see a chain selector like that? What you're saying is the rocket, when it is inside an element that has a class of started. So what I've done, instead of putting it on an after on the button, I put it inside of an icon on the button. So what we're going to do here inside our button, we can actually put in an icon, and the icon element looks like this. So it's just an eye. Rocket. There we go. And now we will get our little rocket. Hooray. And when we hover over it, it's ready to go. And we click on it, it shoots off. And we've got that. And you can take a look at your CSS and see how I've done those animations if you would like to, and if you are interested in CSS animations. So I've done a little animation called zoom out right, and I've done a little animation shake. And you can take a look at what they are doing there, but I'm not going to go into CSS animations too deeply. And yeah, the zoom off might not be the correct animation for you if you haven't got a space themed game. So you can update that if you want to change it. Maybe it jumps out, or maybe it zooms into the page, or maybe it does nothing. It is fully up to you, and I hope you customize your games to look cool. But let's see if our winner animation now works. So if we just jump back into our JavaScript, remember we, on game over, added a class of winner to the body. And then in our CSS, on the winner class, we've put a background of that Betty into the page. So let's see if we can get that working. Yay, that's a bit more of a party. That feels more like we finished a game. So yeah, that's cool. And we can obviously, you can do a bit of perfecting of this. So we could use our VW units that we saw to make the congratulations text fit in the page. You can obviously change all the colors of everything, style this up to be however you would like it to be. And maybe you might want to then add some instructions into the game, so we could maybe indicate to people what it is that they're doing with this game. So in our index.html, maybe above the game itself, we will put in a one that explains this is a typing game. We'll put in a paragraph that says, like, practice your typing skills with a quote from Star Trek. Button to begin. Click the start button. Which gives people a bit more of an indication of what should be happening on the page when they actually land on it. What else could we do? We could maybe change, so we could hide the start game once they've started the game and then show it again. So maybe in a CSS we could do dot winner dot button explain none. No, it's not winner, is it? It's want to add a class into the page when the game is started. Okay, I'm yeah, going into more perfection than we need to. These are things that you can do if you want to expand out your game. So maybe once they click start game, you could, in your JavaScript, add a different class onto the body to let the game know that the game has started. So instead of body class name is empty, you can add a class name of started, which would then hide the start game and hide the paragraph with the descriptor text so that the game sits at the top of the page. You could maybe then change the text to restart game once the game has been won. There's all kinds of fun things that you could do with this. So do play with it, make it your own. This is your game now. And I would really love to see what you do with it. What I'm going to remind you all to do as well is make sure that if you've been following along since the beginning and you've built your portfolio, which we built in HTML, make sure that you take a screenshot of this and add it into your portfolio in your project section so that you can show it off. Make sure that you share the URL in your project section as well. So the really cool thing about Glitch is that we have the ability to actually link to our game. So we can say, here's my game, I can share the link and everyone can play it. Did we add a counter or a timer? You absolutely could do. Yeah, that would be super cool. Like stress everybody out by putting a ticking counter on there. Yeah, love that idea. Absolutely, please make it your own. This is your project now, and this is showing what you are able to do in JavaScript now. So let's talk now a little bit about some of the things that we actually used. So far, while we've been studying JavaScript, we've had a look at what a statement is. We've had a look at our different logical operators. We've had a look at our mathematical operators. We've looked at our primitive JavaScript objects. So we saw what a number, a string, and an object was. But we haven't really looked at much past that. We've just made a very complicated game without too much knowledge of what it is that we were doing. So let's go into some of the things that we are actually using here. I'm just going to stop sharing and make sure that I've got my next slide deck ready for you. So we're going to talk about functions and methods next. And we'll just do a little recap on stuff that we've already covered as well. So first off, what is JavaScript? It's a programming language that runs in the browser. What does JavaScript let us do? As you've seen now, it lets us build slightly more complex features on top of what we could already manage with our HTML and our CSS. It allows us to add more functionality to our pages. It lets us do some fun mathematical and logical operations to actually create things that are functional on the web. Can you remember, so we spoke about this briefly, what do we call the set of rules that define the structure of JavaScript? So things like the symbols, the characters, the things that make statements or expressions. Can anybody remember what that was called? Or does anybody know? Syntax, exactly. Exactly. You got it. So that is what we call the structure of our JavaScript, is the JavaScript syntax. And to that end, do we know what a JavaScript expression is? So if I was to write an expression, it's just a combination of values. Yeah, so an assignment could be an expression for sure. It's a combination of values and functions that are interpreted by the compiler to create a new value. So yeah. And a statement is a standalone execution that doesn't return anything. So we're building expressions and statements to write our JavaScript code. If you want to print out something to the console, can you remember what method it is that you use to do that? Console log, cut that in there in 2 seconds. Love it. So yeah, our console log method outputs to the web console. How do you denote a comment in JavaScript? Can you remember that? // Yeah, exactly. For a single line comment, or if you want a multi-line comment, then /*. closing with a / exactly. Thank you, Pradeep. And anything that you put in there will be ignored by your JavaScript. So when you're writing comments, you're writing it for your fellow humans, not for the computer. So what keywords do we use to declare a variable? Var. Yeah, we could use var, const, var, and let. Exactly. Thank you, Colette. Thank you, Alex. Thank you, Georgie. Sorry, I'm absolutely butchering the pronunciation of your name there. And can you remember what the difference between let and const is? Const can't be changed. Yeah, exactly. So we can update our value later on if we use a let, but not if we use a const. The value of a const cannot be changed. Awesome. So the primitive data types that we learned last week were numbers, strings, booleans, and objects. Can you remember what the difference between equals and equals are? Equals is assignment, exactly, beautiful. So the assignment operator is going to assign to its left operand based on the value of its right operand. And equals, can you remember the name of them both? The equals and the equals? Yes, equality operator, nice, exactly. So we have equals, which is our equality operator, which checks whether two operands are equal. So it checks whether the things on either side of it are equal. And it uses something called the abstract equality comparison algorithm to compare both sides. So what it doesn't take into account is types. It does something called type converting comparison. So it converts them both to the same type and then checks whether they're the same. Whereas our equals is our strict equality operator. And in a strict comparison, we get true if and only if the operands have the same type and the same value. And can we remember what this operator is here? This little pointy guy. Greater than, exactly. And so the greater than operator is a comparison operator. We had a look at those in a previous lesson, and it's used in our logical statements to determine whether something is larger than something else. And crocodiles are mentioned, and we all got very confused. Let's not go down the crocodile route again. What else have we got? Okay, we've got gone through all of those. Can you remember which data type allows you to put extra properties on your variables? Objects, yeah, exactly. Beautiful. So objects allow us to store multiple bits of information, and they're a little bit more descriptive than our other primitive types like numbers and strings. So for example, the example that we had was we had a cat, so it had a name and a number of legs and a cuteness. You might want to save the name, model, and color of a car, or the name, time, and location of a film playing at the cinema. Objects are super useful, and you're going to be using them all the time. The two halves of the properties on the object are called a key value pair. So we had, for example, with our cat, the cat had a number of legs key and a value of 4. So that's our key value pair. And we can give any value to a key value pair. It can be a string, it can be a Boolean, it can be a number. And then if we want to access that property, can you remember how we do that? Dot operator, yeah, beautiful. So it'd be cat.legs, object name dot object key. I love it. There is another way to do it, which we didn't look at. I'm just wondering if anybody knows it. So we can also access it with bracket notation. If we want to, we can do object name, square brackets, and then the property name in quotes, and that will also work. So that's a recap of stuff that we've covered already. Let's move on to some new JavaScript knowledge. And we've already built something that was kind of complicated. And the more things that we build, obviously the more things that we're going to learn. I personally like to learn by doing. And so that's why we built the thing before we talked about the things, which can feel a little bit confusing. And I'm sorry if it felt like I was kind of throwing you in the deep end, but let's talk about what it is that we did now. When we're building things, we want to make sure that our code is as readable as possible and as easy to understand as possible. So when we were writing that game, we used little blocks of code to sort of organize what the game was doing. So if we jump back and just have a look. So we've got all of our variables that we're creating right at the top of the page, so we can say like, okay, these are a bunch of things that I'm going to need to know about. Then we have this block of code here where we're saying, okay, this is doing something that is going to start the game. This block of code here is doing something that is going to check input. Okay, I can kind of guess what that's going to do. This block of code here is going to do something about game over. And when you're writing, you want to try and keep your code as readable as possible so that another human can come to it and understand what it's doing. Not only that, so that you can come to it in 2 weeks' time and try and remember what it was that you wrote. And the way that we do that is by putting it in these nice little blocks, which I've done here, and these are called functions. And functions are just blocks of code which you write to do a specific task. And usually when you're writing a function, you're going to give it a name which is going to describe what it is that the function does. So we've done that here. We had our start game. So you would assume that that is going to start the game. We've got our game over. So you would assume that that is going to do something when the game finishes. Our check input. As much as possible, make your function names descriptive. Make sure that they describe to another human what it is that your code is doing, because the computer doesn't care what you call them. It'll call them and run them. You know, you could call it Fred if you wanted, but Fred wouldn't help you understand what that was doing in 2 weeks' time. And as we've seen, we can call functions from other functions, and almost all programs that you see are going to be made up of function calls. So let's take a look at what a very basic function looks like. So here we have a function which is called say hello. And functions are made up of our function definition, which is just the word function here, and then the name of our function, and then the function body is everything that is inside the curly brackets here. And the code inside this function is not executed until the function is called. It's sometimes, so we either say the function is called or the function is invoked. Sometimes people will call it that. And today, why don't we use, should we use, yeah, let's use CodePen to write some little functions for ourselves today rather than using the console, just because the control enter thing is really annoying. Shift enter even. So let's jump into CodePen. Just have a pen. Okay, cool, awesome. Great effort. Open up the console. You aren't seeing. Oh no, you are seeing. Okay, awesome. And then what we're interested in is our JavaScript. So we are going to try out the function. So we're going to say function. Say hello console.log hello log. And at the moment it's doing nothing. As I said, that function is not going to be executed until we call it or until we invoke it. So let's do that now. We're going to call it, and the way that we do that is with our function name, hello, and some parentheses. So now we can see in our output in the console, hello world is being output because we have called our function. I don't know where the slide's gone. There we go. So functions are defined using our function definitions. And functions are interesting because they can be called before or after they're defined. And this is kind of useful for your code organization. So when I was talking earlier about how we split our code up and how we read it as humans, quite often you'll want to group functions in your files or group parts of your code that is related. And the lovely thing about being able to call a function before you define it is that it means you can keep things that are related close together. So maybe you could have all your function calls and then have all your functions defined further down the page. And why does this work? Defining a function in this way with the function keyword using function name means that your functions are detected by the JavaScript runtime, and the runtime knows that these functions exist. And it kind of, the JavaScript runtime kind of looks through your code and goes like, are there any functions here? Oh, there's one. Okay, I know that this exists. I'm going to just sort of keep tabs on that. And if it's called, I can use it wherever. And this process of the JavaScript runtime doing that is called hoisting. So you can call your function before you define it. And that's a cool JavaScript feature. This doesn't work. So we've seen already we can't do this with variables. So we can't use a variable before we have assigned a variable. Because the JavaScript runtime is like, I don't know what this variable is because you haven't created yet, but it does work with functions. So cool, JavaScript. And there's a handful of best practices to keep in mind when you are writing your functions. And again, these are my personal beliefs. You may disagree, you may meet developers in the future who disagree. But I think that these make your code more readable. So, as I mentioned, use descriptive names for your functions that describe what your function is going to do. Name your function after what it does rather than how it does it. So, for example, if you're writing a function that takes a price and calculates the tax on that price, the function would be called calculate price and tax rather than add all numbers and add 20% to it, because tax might change in the future. So calculate price and tax lets me know that's what this function is doing. So we want descriptive names for our functions. We want to, again, personal choice, camel casing to combine words for your JavaScript function names, where each letter of each new word is a capital. It's called camel casing because it looks like the humps of a camel with each new word. Lower camel casing is what we use here. So lower camel casing means the first letter starts with the lowercase and then the rest of the words start with an uppercase. It's just kind of, it's not a standard, but it's what was used in a programming language called Smalltalk, and it kind of got picked up by a lot of other programming communities. So it's a kind of unwritten standard that we use camel casing for our function names. And then it's important that you keep your functions focused on a specific task. So again, this, I will say this is personal choice, but I think it's better to have functions that do one thing and one thing only, and keep your functions focused on doing keeping your functions focused on doing one simple task is going to make your code easier to maintain in the long run. And then, you know, our naming makes a lot more sense of our functions doing only one thing. We can say like calculate price and tax. That's what this one function is doing. Awesome. I understand everything that is happening inside of this code block. There's a joke out there in the world that naming is the most difficult part of programming. And it's kind of true, like making your code readable. Naming is such an important part of that, and getting that naming right will take practice. But it's something to bear in mind while you're writing your functions. You might find yourself needing to pass information between your functions, which will change the output of the function depending on what information is passed. And this information is called a function parameter, and they're listed in the function definition inside the parenthesis. So here we have a function called say hello, and we are passing it some information. We're passing it a name, and then we can use that information, that variable, to output a name in our console log. And then when we call the function, we give it that information, and that value, that is going to be an argument. So this is a parameter, this is an argument. So let's try that out in CodePen. So we can say, instead of say hello, we can make a function called greet. And that's going to take a name. It's going to be log. Use backticks for hello, and then name. And then we are going to call our function, and I'm going to greet myself. So I'm going to say hello, Joe. There we go. And we can see that hello, Joe has been output to the console. And we can do all kinds of fun things with this. We could do maths with it. So we could create a function called add, which takes two values, x and y. and it's going to console spell dot log y, and then we can call that and say add 3 and 4, and hopefully we will get, there we go, yeah, so we've got 7 output to the console there. So we can have multiple arguments in our function. You can pass multiple arguments. We can have multiple parameters in our function definition, and they can be different types as well. Like we don't have to only pass numbers or only pass strings. Could we return instead of console log? You absolutely could return, but then we wouldn't see any output. So I'm using console log here so that we can actually see some sort of output. If you were returning, then you would be using the value somewhere else in your code. But you absolutely could return, but then we won't see what it's doing. So just for the visual, I'm using console log right now. Back into slides. Cool. So yeah, just to visualize this, we've got our parameter, we've got our argument. And we can define variables in our parameters. We can provide like default values, and we do that by using this equals sign. So we can say the sort of the default value of name is you. And if I want to overwrite that, I can call the function with a value, or I can just call the function and use the default value, which is kind of, it's like saying, if there's no data provided, please set this parameter to whatever I provided here. If there is data provided, use that data. And the cool thing about this is it doesn't affect anything outside of the scope of this function. So what do we mean by scope? So I've seen a few people mentioning scope in the chat already. And function scope is the bit that happens between the curly braces of your function. And it's one of the more confusing things when you start learning about functions and you start understanding how values get modified. So let's take a look at an example. So here we're creating a variable called value, which has a value of 1, 2, 3. And then we're going to console log it. So value is, and then sending it the value. Then we're going to create a function called change number. And when change number is called, we're going to update the value of number. We're going to output and say change number is our new number. When this function is executed, the parameter number is set to the new value. So we're setting the parameter number to be 456 at this point. And when we console log it, what would you expect this line to say at this point? Change number is 456, exactly, because we are inside the scope of this function. However, if we then console log our value again after we call that function, what would you expect this line to output? Oh, I've put a hint in there, which sort of makes it a bit more obvious. What would you expect this line to output? Yeah. So it would say value is still 1, 2, 3. And that's because we are outside of the scope of where number has been updated. Once the function is run and that console log is called, we can see that the original value remains unchanged. And this holds true whether you're referencing a number, a string, a Boolean. So how do we get numbers out of our functions? If we want to be able to create a function that updates a number and then use that elsewhere, we're going to do the exact thing that was mentioned. What would the output be if you called the function change number? Can it see the number outside? Why don't we try it out? Okay, number, setting number, let's keep it the same. And then we call change number with four. Number is 456. Okay, cool. Let's see what happens when we change this to be. So we haven't told it anything about what number is outside of that function. So yeah, it's just, it doesn't know. We haven't created. Awesome. But what if we did want to get this number out? We're going to do the exact thing that, who was it? Somebody mentioned earlier. Can we do a return? That's exactly what we are going to do if we want to get a number out of the function. Up until now, everything that we've done with output to the console, partially so that we can see a visual update. And sometimes that's exactly what we are looking for, especially if we're teaching, but most of the time when we're programming, we want to pass values between our functions so that we can do exciting things. Especially, you're creating a function which is going to be calling another service that does another thing to the value. So what if I create a helper function which is going to perform a calculation and provide a value back so that I can use it elsewhere? I do that by using the return keyword, which is going to return the value that the function has ended up with. And returned values can be stored in a variable, just the same as you could store a literal number or a string or a Boolean. Anything that you can return from a function can be set to a variable and then used in another function. It could even be another function. We could return, we can return a number, a string, an object. We could return another function. That's when stuff gets really exciting. So let's take a look at our add function that we created before. We can add a line in it that is going to return. So we've console logged X and Y. We could also return X and Y. And then we're going to assign that to a variable. So here what we're doing is saying, create a variable called sum and set sum to the value of what is returned by this add function. So that's super cool. That means we now can pass data into functions. We can get data returned out of functions, and we can use that in other functions. But the data that we get isn't going to be affected by anything that happens in subsequent runs of that function. And this is a great way of it's a great way of reducing bugs in your JavaScript. So naming your functions well, having your functions only do one thing, and then passing values between your functions with your return is an easy way to keep track of what your JavaScript is actually doing. If we want to pass an object to a function, that works slightly differently. So we had a look at objects before, and when we use objects in JavaScript, the variables that we create don't actually contain the data that the object stores. And we spoke a little bit about that, about the fact that even if we create a const called object, we can still update the data that's inside that object, because the data is actually stored somewhere else in the computer's memory and is managed by the runtime. And our object contains a reference to that bit of memory. So if you pass an object to a function like change number, you're copying the reference and not the data itself. And because you're copying the reference, when you modify the data using the parameter, let's write an example. So say we've written a function called change number, which takes an object and it uses object.value. So it's getting the value things very well. And then it's outputting the value of that. And then we pass our object to that and console log it. We are getting that updated value. Let's try and explain it better. We're copying the reference. When we modify the data using the parameter object in change number, it's referring to exactly the same piece of memory. That means when we change the data that is stored in that object, it affects the code that runs outside of the function. So if we run this second console log, it still has the updated value because we've modified the original data and not a copy. And this is a confusing thing about JavaScript, and it feels like a confusing thing to learn when you're first programming it. The way that I like to think about it is, imagine you're a builder on a building project, and you're going to visit a house to do some work, and that house is in a real location somewhere in the physical world. If you write down a copy of the house's address on a piece of paper and give it to another builder, they will be able to turn up at the exact same house. The address that the house points to is a physical location in the real world. There's a physical building. And if you both modify that same house, that house is going to change. In the same way, a reference points to a location in the memory of your computer, so you can modify data using a reference in more than one place. That same piece of data will change. So objects act slightly differently to our other JavaScript primitives when we are updating them, when the data itself is copied. Yeah, it's just a thing you need to remember. It's a gotcha that can get you. But yeah, don't worry about it too much. Let's talk about different ways of defining a function. So we've looked at the moment the function keyword, and we don't have to give functions a name. We can make what we call anonymous functions, which are functions that don't have a name, so there's no name after the keyword. So here, this is an anonymous function. We have just the word function and our parenthesis. And what we're doing here is we're saying, here is a function with no name, and it's going to console log an anonymous function that isn't called because it never does anything. The runtime goes through and goes, oh, there's a function, but it never gets called. It doesn't, it never gets run. And this might seem counterintuitive after going through some of the examples where we have declared functions for our code to use. But let's look at places where anonymous functions might actually be useful. So in JavaScript, functions are described as first class, which means that we can store them in variables, we can pass them as arguments, and we can change what they do while our program is running. And just like we have a literal string or a number, anonymous functions are kind of like a literal definition of a function, that they work like a string or a number. And when you define an anonymous function, it doesn't do anything. You're just defining a piece of code that maybe will be used later on. And if you wanted to call an anonymous function without assigning it to a variable, you have to add this little open and close bracket on the end here, just like you would if you were calling a function with a name. So, you know, if we had function name and our parentheses to call before, like this, we can create an anonymous function and call it immediately using these little parentheses here. This is a little bit confusing to look at because there's a lot of brackets and it feels a bit ugly. But what we've done here is we've created an anonymous function. It doesn't have a name. It's not being assigned to anything, and it's being called as soon as it's been created. But if we don't call it, so if we don't put those brackets in, it's never going to be used at all. So let's have a look at when we might actually want to use this. Anonymous functions do not have a name. Exactly, that's why they are anonymous. Because functions are first-class citizens in JavaScript, we can assign an anonymous function directly to a variable. So you see here, we have created a variable called myFunction, and we're creating an anonymous function, which is just going to be assigned directly to that variable. Then we can call that function just like we call any other function. So this is kind of cool, but you might be thinking like, why? why would we do this when we already have the function keyword? Why on earth is there more than one way to define a function in JavaScript? And it's all about where you're allowed to call them. So we talked about hoisting and the fact that we could call a function before it was defined. And with an anonymous function, we can't do that. Our code will throw an error before we even get there because something else hasn't been defined at this point. So we already knew that you can't use variables before they are defined. If we are assigning an anonymous function to a variable, we can't use it before it's defined. It's no different from any other any other variable. You can't use it before you declare it. So if we want to correctly assign a function to a variable, we have to use it after it has been declared. So we declare our variable, then we use it. And that's kind of cool. It again is a way of making sure that you don't create bugs in your code. So if you want to make sure that you can't use something before it's defined, you might want to use an anonymous function assigned as a variable. So we've taken a look at two different ways to define functions using function definitions and by assigning anonymous functions to variables. And we can also mix and match these two styles. So a function created as a function definition can also be assigned to a variable. And this is important because lots of places in JavaScript we need to use functions as if they were variables. So it's important that however we define our functions, we can do exactly that. So here's an example here where we have created a function and then we've set that function to a variable in a variable and we're able to call it. And the reason why I'm taking so much time to go through how functions can be assigned to and work just like variables is because there's an awful lot of APIs in our browser that work exactly like this. And we've seen a few of them as we were building our little game. And they require something called a callback in order to work. And there's nothing special at all about a callback. It's just a function that you pass to another function that is called by that function when something happens. And a nice example of a callback is set timeout. So what set timeout does is it calls the function that is passed to it after a certain amount of time has elapsed. So in this example above, we are calling set timeout. So we're saying, I want you to run this function after a certain amount of time. And then what we are doing is, so we give it the function that we want to call and we give it a time in milliseconds. And we can do the exact same thing by giving it an anonymous function and a time in milliseconds. This works because functions are first-class citizens. We can pass them as arguments and store them in variables. So if your function is very small or it's not doing a huge amount of logic or a huge amount of work, you could pass it directly like this. You could pass it as an anonymous function because this function is only doing a console log. That's kind of cool. We could use it in this way. Earlier, we talked about how objects use references, and those references are what gets copied when they're copied into a function. Passing functions as parameters works in exactly the same way. So just like objects are put somewhere in memory by the JavaScript runtime, all your functions live somewhere in memory as well. And when a function is passed as a parameter, you're actually copying a reference to that function. That's just a piece of interesting an interesting fact. You don't need to really remember that at this point. And we don't have to use an anonymous function. We could instead define a function and then pass that to set timeout instead. So in this example, we're using our hoisting again, and we're relying on the fact that the JavaScript runtime allows us to define a function further down the page than when we call it. So here we have said set timeout, and timeout action is the name of my function. I want it to run after 3 seconds. And then I'm defining this function timeout action, which is going to console log after 3 seconds. And the choice of which one to use, so this anonymous function or defining a function, again, is kind of a legibility thing. So if your function is small, maybe you might want to use an anonymous function. If your function is doing lots of complicated stuff, you might want to split it out and give it its own function definition. Yeah, it's all about what you think is the most readable. Oh, and if you thought we already had enough different ways to define functions, there are yet more. So there are shortcuts in a lot of common programming languages, including in JavaScript, which is a way to define a function using something called an arrow function. And it uses a special operator which looks like an arrow, which is this thing here, which is the equals and the greater than sign. So by using this, we are able to just skip the function keyword. And this way of defining a function is what we call, well, using this arrow function is something called syntactic sugar. And it's something that is added to the programming language to just make it look a little bit nicer, make it look more readable. Means you've got less sort of junk on the page. You know, we don't have to have the word function in there. We can just see this nice arrow here and know that we are creating a function. And like, yeah, this looks nice. And this works really nicely once you start to have more parameters. You can start to see that it becomes a little bit more readable, but it works exactly the same as previously when we had one-on-one parameters. We place our parameters in between the parentheses when we are defining our function. We can also use default parameters in exactly the same way. So we can set a parameter and we can set a default value to it. It works exactly the same way as your regular function definition. It's just you've got a little arrow in there. And if you want to make your code even more concise, if your function only has a single parameter with this arrow function, you can exclude the parenthesis, and then it kind of looks even neater. And arrow functions really come into their own when we're using our inline functions, like our set timeout. So when we pass this anonymous function here, like this looks a bit messy, we can pass this nice arrow function here, and it just removes a lot of the syntax that is required to write this piece of code. It reduces what we call boilerplate code, that repetitive code that has no real meaning. It's missing. You are correct. Yes, there should be an open curly bracket on that line. Good spot for you. Whew. Okay, we're nearly done. We're nearly done. There's just a few final things to talk about. We talked a little bit about methods when we were writing our little game. And there's a special type of function which is known as a method, which you've already been using a lot. Every time you use console.log, you are using a method. And what makes a method different from a function is a method is a function which is a property of an object. So the object that we're talking about here is the console. And the console has a bunch of different methods, one of which is log. And you will hear a lot of developers use the term method and function interchangeably. So people might be talking about methods and they're talking about functions and vice versa. Whew. Okay, that was functions. Time for a recap. We have had a look at how we define a function with a function definition using the function keyword. We've had a look at defining anonymous functions, so using the function keyword with no name. We've looked at assigning functions to variables, both with our named functions and our anonymous functions. We have had a look at passing data to functions as arguments, using data that is passed as parameters inside the function. We've looked at returning values out of functions so that we can use them in other functions. We've had a look at callbacks, which is when a function calls another function. we have had a look at arrow functions, and we've had a really quick talk about methods. And we have used a lot of methods in our code example. Oh, glitch has gone to sleep. Wake up. Okay, good. So let's find an example. I'm sure we've used some methods in here. Yep, so we've got our starts with, we've got our trim. These are all methods that are available to us through browser APIs. So I hope that is sort of demystified. Replace all, yep, exactly. That's also method. I hope that has sort of demystified a little bit of what we did when we wrote our game. So what it would be really cool for you all to do now is just have a look at how you've written your game, whether or not you want to change, update any of the functions that you've written, whether you want to add in any more functionality, whether you want to change the naming, change the order that we're doing things. Yeah, and I would really love to see what you've built. So if any of you are feeling brave and want to share the links to your games, I would it would make my heart very happy to see what it is that you're building. Don't forget to update your portfolio. As I said, Glitch also has or used to, a method of, yeah, so we can also, we export to GitHub. Oh, it has a Git URL. Let's have a look at that. So has it created me a GitHub account? Okay, I don't know what to do with that Git URL. I'll need to look it up. Make sure that you put your project on GitHub as well, so that you can link to it from your portfolios. Yeah, do share your URLs. I would love to see them. Next week, we're going to talk a little bit more about arrays, which we haven't covered yet. Yay, thank you for that. I love it. Oh my God, Lord of the Rings typing game. Look at this beautiful thing. Oh, we might need a bit of a higher contrast text color there. I love it. I love it so much, Colette. It's so good. Yes, I will absolutely share the slides for today and the URLs for all of my Glitch projects. Yeah, so on Wednesday, we'll talk a little bit about arrays, which we haven't covered yet, and we will move on to our next project, which is going to be a to-do app. Good job today, everybody. Thank you again for being so active in the chat. It really helps me. And I will see you all on Wednesday, and have a lovely evening.